Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Trace Amounts, or actually, if it were French, it would be Tre Amount. I don't know how to... Tres Amounts. So you still would have to trace, I guess. Tres Amounts, or something along those lines. And it's by Nordy and Calvin Ball. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. In addition, dashed lines and small numbers are part of non-overlapping cages that each span exactly 3 cells. Digits in the cage do not repeat, and they sum to the corresponding small number. So, for example, this cage is essentially 3 digits, 3 cells, adding up to 10. You cannot have repeats in it. It could be these 3, it could be these 3, it could be these 3, potentially. We just know this is a border here of a cage. Similarly, we have this cage is a 17. It could be something like that. It could be something like that. It cannot be something like here, because then this would be overlapping with another cage. And you cannot have overlaps in a cage. But each cage is exactly 3 cells, and there are no repeats, and they must add up to the corresponding small number. And those are the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Here can be 3 cells. Either could be this one, this one, this one. Those are the only possibilities. Here, 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 or here. Either way, the 3 digits have to be in box 1, and they must add up to 6. So it must be 1, 2, and 3, which means 1, 2, and 3 cannot be anywhere else in this box. So specifically, it can't be here, and it can't be in this cage. So this is at minimum, these 2 digits are at minimum 4 and 5, because you can't have overlaps, and remember the 1, 2, and 3 are eliminated from the rest of this box. So this has to be then 4, 5 with a 1, and the 1 cannot be here, the 1 has to be one of these 2 cells to form a 3-cell cage. This must be a 1, so this has to be 2 and 3 here. Right? Because 1 cannot be in the remaining box. It has, so therefore that eliminates 1 from the rest of the box. And we know this is a 3-cell cage, which adds up to 6, which is 1, 2, and 3. So it could be with either here, can't be here. It's either here or one of these 2 is a 1, but we're not sure which. That leaves this as 4 and 5. Well, we don't know which way it goes. It cannot be 3 digits in the box, because that's at minimum 4, 5, and 6, which adds up to 15. So it has to get out of the box, which means it must be these 3. So this is 4. It cannot be 4 and 5, because that would eliminate all possibilities for that cell. So this must be 4 and 6 then, which forces this to be a 1 to add up. This therefore cannot be 1. This can't be a 1. This must be then a 1. Well, where is the 1? This has to be a 5 because of the 4, 6 pair in the row. This can't be 5. This must be a 4. This can't be 1, so this must be 2, 3. Where can the 1 be in box 1? It cannot be any of these. It has to be here. And remember, this 3-cell cage must contain a 1, and it must be in this box. So this must be 1. This is 2 and 3 here. We have a 1 here, which means whatever cage is a 2, 3, 5 cage sorry, whatever cage is a 10 cage here, it can go down here, but it can't contain a 1. It could go here, but then it can contain a 1. It could go here, but it couldn't contain a 1, or here. So in this cage, it's 2, 3, and 5 at minimum. This then has one of these is a 5. I guess one of these 3 is a 5. The remaining digits in box 2 are 5, 7, 8, 9, but this can't be 5 and this can't be 5. So one of these 2 is a 5. This 12 cage cannot contain a 1, and it cannot contain a 5. If the 2, 3, 5 is in this box, the problem is this becomes at minimum 4, 6, and 7. And so that cannot work. Therefore, this cage has to go outside the box, and the only place where it can go outside the box... Actually, I guess this could be a 5 here. But the problem is, okay, if it goes here, here, and this is 5, this would then be 2, 3, 2, 3, 5. This would be at minimum 3, 4, and 5. I guess that's possible. And this could be a 3. Oh, but there's no 4. Well, I guess it could be 3, 4, 5 this way then. Okay, that is possible. Wait, no, you can't have 2 or 3. It would be 4, 5, 6 minimum. So if it goes this way, and this is 2, 3, 2, 3, 5, this is at minimum 4, 5, and 6, which is 15. Okay, so that's the reason why I can't go this way. So it has to either go this way, or it goes this way, or this way. But it can't be in the entire box, because then that would be 2, 3, and 5 in the box, which means this is minimum 4, 6, and 7, which is 17. So it has to go outside the box. This is the only way to go outside the box. So let's mark the cages. This cage is over here. This cage has to be here. This cage is one of these two, but we don't know which. This cage is here. This cage must go outside the box. And this cage has to at least go here, but we don't know which one it goes there afterwards. So, it has a 5 here. This cannot contain a 4. Oh, it can't contain a 4 here. It cannot contain a 5. So what's the minimum then? It's either 2, 4, and 6. And 3, 4 would have to be with 5, which is not allowed. So it has to be 2, 4, 6, and it has to be then these 3 cells. So the 4 has to be here. This is 2 and 6. So this can't be 6 here because of that 6. So this is 2, which forces this to be 3, which forces that to be 2. This becomes a 6. This has to be 3, 5, and that's a 2. Okay. Let's see. We have a cage here, so it has to go this way, and we don't know where it goes. We have a cage here, but we don't know which way it goes. We have a cage here, but we also don't know which way that goes. Same here. Same here, interestingly enough. Okay, this is blue. And this is, we're gonna make that, I guess, yellow. Too many yellows. Let's make this green. So this 10 cage must have a digit that has a 1 or 2, right? It's either 1, it could be 1, 2, 7, but that's probably not the case. Actually, that can't be the case, because if it's 1, 2, 7, where does it get the 1? Cannot be these, so it would have to get the 1 here, but then this would already be 3 digits. So it's 1, 2, 7, 1, 3, 6, 1, 4, 5, or 2, 3, 5. These 3 digits are 7, 8, and 9. These 3 digits are 6. These 4 digits are 6, 7, 8, and 9, but this can't be 6 and this can't be 6. Okay. To add up to 1, so 127 doesn't work. 136 could be 1 with 3 and 6. That's possible. 145 would be the same. 1 here with 4 and 5. Or it's 235, in which case it could be 235 here. Or 235 that way. 2, 3, and 5. Either way, one of these cells is part of the cage, but we're not sure which. This blue cell requires 1, 2, and 3. Sorry, this blue cage requires a 1, 2, or 3. Well, the only way to get to a 2 is to go left twice. So this has to be the blue cage, which makes this 2. This then has to be 1, which makes this a 3. Okay, so this can no longer contain a 1, because this 1 has to belong to this yellow cage, because the 1 is not available anywhere else. And it has to be 2, 3, and 5. So this is a 2, which makes this 3, which makes that a 2. This is part of the green, because there's no other place to get the 2. And we need a 3 and the 5. So it could be this way. This is 3 or 5 either way. These two digits, what's the minimum? Well, okay. What are the remaining digits in column 9? They are 1, 5, 7, 8, 9. 1 cannot be here, so this is 5, 7, 8, 9. 5, 7, 8, 9. These are 1, 5, 7, 8, 9. Can you add up 3 digits to add up to 17 with just 1, 5, 7, 8, and 9? Yes, you could have 1, 7, 9. That's possible. What are the remaining digits in column 8? They are 4, 6, 7, 8, 9. Okay. That's not too helpful there. This yellow cage must be 7, 8, and 9 specifically, so this cannot be 4 or 6 here. So what are 3 digits that don't have 3 or 2, 3 or 2 or 3 that add up to 17? 179, obviously. And then I think it's only 4, 6, 7. Oh, 4, 5, 8 works also. That's pretty broad. Okay, this orange cage is going to be in box 6. So can the yellow cage also be all in box 6? The answer is no, because if the yellow cage is all in box 6, it would require 7, 8, and 9 to be in it. Therefore, this is at maximum 4, 5, and 6, adding up to which adds up to 15, which is not big enough to add up to 17. So the yellow has to go outside box 6. So it could go here, here, or here. We're not sure which. So these are the possibilities for this. Oh, this cannot be 1 because of the 1 in one of these two cells. What are the remaining digits in column 1? They have to be 4 through 9, and this has to be specifically 7, 8, and 9 because we have 3 digits adding up to 24. This must be 4 through 9 because we have 3 digits adding up to 21, and 4, 8, 9 is the minimum digit possible. 2 has to be one of these two here. What else? Two. Other two. The other two has to be one of these two digits. Here in row 4. Or sorry, box 4. I guess. If it went this way, all three of those would be 7, 8, and 9s. So these two digits could not be 7, 8, or 9. It would therefore be 1 and 5. But that doesn't add up to another with another digit to add up to 17. So that's not allowed. So this cannot be the other yellow. It has to either go here or here. Either way, this is the other yellow, which means this is 7, 8, or 9. This then cannot be fully 7, 8, and 9. Sorry, can't be 1, 7, 9. So 1 can never be in here. 1 has to be here and not part of the 17 cage. Therefore, this must be 5 and 8 because, again, you can't have... It's either 4, 5, 8 or 4, 6, 7, but you can't have both 4 and 6 in this orange cage. So it would have to be here. This would be 4. This would not be 8, so this is a 7, 9 pair. This 5, 8 pair means this can't be 5. This is a 3, which forces this to be 5 and part of the green cage. And this is a 1 and part of the yellow cage here. This has... One of these two is an 8. We're not sure which. This is the remaining digit, which is a 6. So this cannot be 6 here. Sorry, this can't be 4 here, and this can't be 4 here. This can't be 5, 8 pair because of the 5, 8 pair in the column. This cannot be 7 or 9. So 1 has to be one of these two cells. This can't be 4 or 6 anymore. The remaining digits, so this can't be 5 because of the 5 in the column. So this is 8, which makes that 5. The remaining digits in row 4 are 4, 6, 7, 9. Which means this can't be 4. We have... This then cannot be... This red cage cannot be all in box 4 because that would eliminate two of the 4 possibilities in these 3 cells, and therefore would make this a 4, 6 pair and 3 cells, which is not allowed. So this red has to get outside the box, and the only way it can go is this way. So therefore it goes there. I mean, it can't go here because that's part of another box. That would be the only other way. So it has to go this way. This can't be 7 or 9, so this is an 8, which means this can't be 8. This is a 7, 9 pair, so now we can eliminate 7, 8, and 9 in the rest of column 1 because of the 7, 9 pair and the 8 in the column. So this can't be 7 or 9. This can't be 7 or 9 or 8. We have a 4, 6, 7, 9 quadruplet in box 4, which eliminates 4, 6, 7, 9 in the rest of the box. Therefore, we're looking at 1, 2, 5, and 3. This cannot be 2 and 5. We now have a 1, 3, 1, 3 pair, which eliminates 1 and 3 in the rest of the box. So this can't be 1 or 3. So this is 2 or 5. This can't be 8. So this can't be the last cell cage of the remaining cell. So this must be 8 here. This is 1 with this. I don't know why I missed that. This is also 1. So it cannot be 7, 9, 7, 9 because of the 7, 9, 7, 9 pair in the box. Wait, this can't be 1. We have a problem here. Unless this could be 8 here? This has to be 4 or 5. Is this considered... Huh. I thought the dashed line limits where you can go. Like, you can't go... Well, I mean, the only time I use that is here. The remaining digits here have to be 4, 6, and 3, right? Which eliminates 3, 4, and 6 in the rest of the box. So this can't be 4, 6. This can't be 5. This is 7, 8, or 9 here. But we have a this is not right. This cannot be right. Yeah, this is all... I think I might have to start over and make sure that my logic is sound. Okay. We'll keep the time and just restart. Again, this 3-cell cage cannot overlap with any other cage. It has to be in box 1. So this cannot be 1, 2, or 3. This cage is part of it. So this is 4, 5, and we have a 1 in one of these cells. We have 2 digits adding up to 6, and it cannot have a 1, so this has to be 2 and 3. That makes sense. Okay, so this is specifically green, and it's 1, 2, or 3. This is pink. One of these is pink. This we're making yellow. This is orange. This is at minimum 4, 5, 6 if it stays in the box. Cannot go to here because that would be part of another cage. Can't exit out this way. It has to exit out this way. It cannot be 4, 5, 4, 5, and 2 because that would eliminate all possibilities for that cell. It has to be at least 4 and 6, which means the 1 has to be here, which means this can't be 1. So this is 1. And this is all pink. We need a 1 in this 3-cell cage. Well, 1 can't be here or here. It has to be here. So this is 2 or 3. This is 2 or 3. These are part of the green cage. We're making this red. This we're making blue. I think we made that red. This is pink. Make that green. This is yellow. We make that yellow. We'll make this blue. This we can make orange, and this we'll have as red. This can't be 4 because of the 4, 6 pair in the row, so this is 5, which makes that 4. This has to be 6, 7, 8, 9. This has to be 5, 7, 8, 9. But this can't be 5, and this can't be 6 because of the 4, 6 pair. This red has to be completely in this box, which means it's at minimum. Okay, so the 10, one of the ones has to be with this yellow, and it cannot be here, cannot be any of these. One of these is a 1. Which means 1 can never be in this blue cage because it can go at most here. So it has to be a 2, 3, 5 triplet. If it tries going 2, 3, 5 here, this is 5, this is 2, 3. This is at minimum 4, 5, and 6, and this red has to be in box, all in box 3. So that doesn't add up. So it cannot go this way. It cannot all be in box 3 because then again this is minimum 4, 6, and 7, which adds up to 17. So it has to exit out of the box, which means this is 2, 3, and 5. This can't be 2 or 3 because of the 2, 3 pair in the row. So this is 5. This is 2 or 3. This is 2 or 3. We need 3 digits adding up to 12, and the minimum would be, cannot be both 2 and 3 there. So the minimum would be 2, 4, and you can't have a 5. It's 2, 4, and 6. And that adds up to exactly what we need. So this has to be 2, 4, 6 then. We need a 4. 4 cannot be here. 4 cannot be here or here. 4 has to be a here. This can't be 5. This is part of the red cage, so it has to fill this way. This can't be 2 or 3 because of this 2, 3 pair here, which forces this to be a 6, which makes that a 2, which makes that 3, which makes that 2. This is 7, 8, or 9. This is 7, 8, or 9, and this is 7, 8, or 9 as possibilities. This can't be a 6. This can't be 2, so this is 3, which makes that a 2. Again, this blue cage must contain a 1, 2, and a 3. If it tries going any of these sets, it can't work because there's no 2 possible. So 2 has to be here and available. This can't be 2 or 3, so this must be a 1. And this must be a 3. 1 cannot be here because one of the ones in box 5 has to be here. The 1 in box 5 has to be one of these two. The 1 cannot be here, so this can never contain a 1. It has to contain a 2. So this is a 2, and we'll make that pink. This is then 3 or 5. The remaining digits in column 9 are 1, 5, 7, 8, and 9. But these can't be 1. The remaining digits in column 8 are 4, 6, 7, 8, 9. But this can't be 4, 6 because this has to be 7, 8, or 9. These digits are 4 through 9 because it has to contain, it could be 4, 8, and 9 at minimum for the minimum digit. This is 7, 8, 9. This cannot be 6, 5, 7 here. This can't be 1 here. I guess we can't assume this is a border of a cage. That seems really strange, though. To do that. I don't know. Huh. This can't be 2 because of this 2, so this is a 3, which makes that a 2. 2 in column 4 has to be one of these two cells. 2 in row 6 has to be one of these two cells. This is 4 through 9. 4 through 9 here. Yeah, so the question is, does this red cage, can it actually go out here? I mean, possibly. But that's really weird to have the cage dash line be there then. That's very strange. I think we might have to assume that. But that causes all sorts of complications, right? Otherwise, one cannot be either of these. One has to be one of these two. If it's 1 is in the 17 cage, it must specifically be 179. The only other possible combination would be 4, 5, 8, or wait, yeah, 4, 5, 8, or 4, 6, 7. But it can't be 4, 6, 7 because okay. So then what are the possibilities? 179 or 4, 5, 8. If it's this could be 1 with 7, 9, 7, 9. If it's 4, 5, 8, though, this becomes a 3. 5 can no longer be in the rest of the box, so to get outside the box, we need a 5 here. The 4 would be here. Again, that's the problem with this, right? If this is 4, 5, 8, This becomes 4, 5, 8. Therefore, this becomes a 3. This has to be 5. This has to be 1. This can't be 4 or 5. 5 and 8 cannot be here anymore. This must be a 1. This can't be 4. So this can't be 7 or 9. It's a 6, 8 pair. Which forces this not to be 6 or 8. This is 7 or 9. We have 6, 7, 9, but again, if we're reading this way, this has to be a 7, 9, 7, 9 pair, which forces this to be 6, which means this can't be 6. This is pink. This is yellow. This 5 means this can't be 5, so this is 8, which makes that a 5. So we have 1, this is 3, 7, 8, 9. 1, 3, 7, 8, 9. This can't be 5. This can't be 8. So we have a 4, 6, 7, 9 triplet. This can't be 7 or 9 because of the 7 or 9, 8 and 9 triplet in the column. So this is 4, 6. This cannot be 7 or 9. Where are the 7 and 9 in box 5? They have to be in these two cells because it cannot be here. But we have a 4, 6, 7, 8, 9 triplet here. Okay, this has to be a 7, 9 pair here. So this is 7, 9, 7, 9, which means 8 has to be one of these two. This can't be 8 anymore. This has to be 4 and 5 here. This is a 7, 9, 7, 9 pair, which means this can't be 7 or 9. It must be 8. But how do you have 3 digits at... Oh, did I mess that up here? I think I messed this up. This can contain a 7 and a 9 here. Right. Okay. So that's where I messed up. It actually has to contain 7 and 9, 7, 9 here. Okay, that makes more sense. This cannot then be 4, 6. This is a 7, 9, 7, 9 pair, which eliminates 7 and 9 in the rest of row 4. We also have a 6, 7, 8, 9 quadruple, actually a 7, 8, 9 triplet in column 2, which eliminates 7, 8, and 9 in the rest of the column. Therefore, this can't be 7, 8, and 9. This is 6. This can't be 6. The rest of the column can't be 6 through 9, so it's 1 through 5. This can't be 1 or 3 because of the 1, 3 pair in the box. This can't be 8. This can't be 1, 2, or 3, so this is a 4, 4 or 5 here. These can't be 8 here. The rest of column 4 must be 2 through 6. But this can't be 2 or 5. This can't be 2 or 3. Okay. What we know for the 21 cage, I guess it could go this way. This can't be 5. Where is the 5 in box 2? It must be here. So this is 5. These have to be 4, 5, 6, 7, 8, 9 as the remaining digits, but this cannot be 4, 5 here. These cannot be 5. This must be a 3, 4, 6, 8 triple pair combination. This has to be 2, 4, 5, or 6, but it cannot be 4 or 5 here. I guess it has to be 7, 9, 7, 9, 8 here. Assuming this is blocked off, right? So we need the other 7 or 9, so it definitely has to be there. Well, that's why we were assuming that this was a border. So if that's a border, then it has to go that way, which means that's an 8. So this cannot be 8. This cannot be 8. One of these digits is a 1. Okay, so that kind of works. This can never be a 7, 9 pair here because it would add up with 5 to add up to 21. I guess it could go this way, actually. I didn't think about that. In fact, I think it has to go that way. It requires 2 digits from 7, 8, and 9, but we know it cannot be a 7, 9, 7, 9 pair. So this is either 6, 7, 8 this way, or 4, 8, 9. Either way, this is an 8. So this is 8, and it must be part of this triplet, because we need 2 digits from 7 and 9, and this can't be here. And this can't be 7 or 9. This can't be 7 or 9. And the 7 or 9 pair would add up with 5, so that doesn't work. So this must be 8 with 4, 9, or 6, 7 here. Okay, we have 3 digits adding up to 17. It requires 1 digit from 7, 8, and 9. So that means it cannot go this way. It could go this way. So it could go either here or here. It cannot go straight down. Can't go here. Okay. So 8 cannot be here. 8 couldn't be here. 8 can't be here. Where is the 8 in box 3? It has to be here, which means this can't be 8, which makes that an 8. This needs a 7 or a 9. If it goes this way... what are the digits that add up to 17? One requires 7 and 9, so it cannot go down this way and add up to 7 and 9 here. It could go this way. 2 requires 6 and 9 or 7 and 8. So it could go something like 2, 6, 9, or 2. This cannot be 2, 6, 9 that way, because that would eliminate all possibilities for this cell. Oh, this can't be 4 because of this 4. Okay, well, that helps a lot. This means that's a 6. This is a 2. These has to be a 4, 5 pair. This can't be 6, so this is 4, which makes that 9, which makes that 7. Neither of these could be 4. We have a 4, 5, 4, 5 pair in column 2, which eliminates 4 and 5 in the rest of the column. So this can't be 4 or 5. It could be 4, 5, and 8. But if that were the case, this wouldn't work. Right? Because 8 can't be here. Or it could be 3, 5, and 9. And I think that's what it has to be. Right? If it's not, it can't be 2, 5 with another digit, because that requires 10. So it would have to be 3, 5, and 9. It cannot be 4, 5, 8 here, because there's no access to an 8. So it has to be down here, and this must be 3 and 5. So this is 3, this is 5, this is 4. None of these could be 4. This can't be 3. This can't be 3. This can't be 3. So this is 1, which makes that a 3. This 1 means this can't be 1, so this is 2, which means this can't be a 2. Where is a 2 in column 4? It has to be here. This can't be 8 or 9, so this is 7, which makes that 9, which makes that 7, which makes that 9. Therefore, that's a 7. This is a 9. This can't be 7, so this is 9, which makes that a 7. So this becomes a 5, 6, 9 triplet, which eliminates 5, 6, and 9 in the rest of the box. So this can't be 5. This is 4. This can't be 6 or 9. It's 7 or 8. And this is 1, 7, 8. And this is 1, 7, or 8. So 5, 3 requires a 9. So it must go this way, which makes that a 9. So neither of these could be 9. None of these could be 4. Oops. We have a 5, 6, 5, 6 pair in row 8, which eliminates 5 and 6 in the rest of the row. These can't be 6. This can't be 7 here. This can't be 4 because of this 4. This 15 cage now, what could it be? This is, what are the digits remaining here? We have 1, 4, 6, 7, and this can't be 9, so this is a 7. So 1, 4, and 6. So this is 1, 4, and 6, and this is 1, 4, or 6. What are the possible digits in the rest of column 3? We have 3, 4, 3, 4, 6, 8, and 9. Well, this can't be 3 or 9, so this is 4, 6, 8. This could be 3, 4, 6, 8, and 9, so that's still wide variety. Things that add up to 15 with no 2. You could have 159 or 168, which would have to access this way. So it could be 159 or 168. That's possible. You could have a 3. So that would be 3, 4, 8, which could be 3, 4, and 8. Or 3, 5, 7, but the 3, 5, 7 doesn't access the 7 with a 5. So 3, 5, 7's out. So 3, 4, 8 works. 1, 5, 9 works. 1, 6, 8 works. What about 4? If you have 4, you specifically have to have 4, 5, and 6. But that's not well, it could be 4, 6, 4, 6, and that's 5. But that doesn't work because that would eliminate all possibilities for that cell. Okay, so let's look at the possibilities again. 1, 5, 9, and it would have to go, it could be, this can't be 1, so the 1 would have to be here. You need a 5 and a 9. I guess the 9 would have to be here. And the 5 would be either here or here. But if this is 1, 9, 5, there's no place for 3 in the row. So this can't be, it can't go this way. It would have to go here. So 1, 9, 5, this would be 3, this would be 6. That seems okay. 1, 6, 8 would need the 1 here again, because you need access to the 1 and it can't access that one. I guess it could go this way though. 1, 6, and 8, but that would eliminate all possibilities for that cell, which is not allowed. So it would have to be 1 here again. So this is 1 in both cases. You need access to 6 and 8, but this is not 6 or 8, so it would have to go this way. 6, and then that's 8. So this would be 3 both times, if that's the case. 1, 5, 9. Oh, where's the 4? No, we didn't say that was a 4 here. If this is 1, 5, 9, this would be 3. There would be no place for 4 then. So it cannot be 1, 5, 9. Okay, so that's out. Then it has to be 1, 6, 8 here as a possibility, which would make that 3. This would be 5. This would be 4. This would be 8, 7, 9. That seems okay. Oh, except 9 wouldn't be possible. Okay, 9 has to be one of these 2 digits. 3 has to be one of these 2 digits. Okay, so we tried 1, 5, 9. That doesn't work because 5 can't be here. So it would have to be 1, 5, and 9, which would force us to be 3. 4 would not have a place in row 9 then. 1, 6, 8 doesn't work either. Because if it's 1, 6, and 8 here, if we tried 1, 6, 8 this way, it eliminates all possibilities for that. So also, we don't have a 3. And if we try going this way, there's no 9 in those two cells. Okay. 3, we could have 3, 4, 8. It cannot go 3. Well, I guess it could be 3, 4. No. One of these is 9 again. So if it's 3, 4, 8, this would have to be the 3. So this would not be 3 either way. It cannot be 3, 5, 7 again, because we tried that there. And this can't be 5 or 7 or 3. So if it's 3, 4, 8, this would have to be 3. And you have 4 and 8. So this would be 4, this would be 8. So if you have 3, 4, 8, this would be 1. This would be 6, this would be 5. But then the problem is this would also have to be 5. Right? Because again, you can't go 3, 4, 8 this way because the problem is one of these has to be a 9. So that means 9 can never be here, right? 9 can only be with 1 and 5 to add up to 15. And a 2 and a 4 if that were possible. So this can't be 9. This has to be 9 because we tried 1, 5, 9. It just didn't work. Any way we tried it. Because then this would be... yeah. It just doesn't work because if this is 9, 1, 5, we don't have access to a 4. So this is always 9. This can't be 7. This must be 8. This can't be 9, so this is 7, which makes that 9. Okay, yeah, I don't know why I didn't figure that out in the first place. So 9 does always have to be here anyways. This can't be 8 or 7. This must be 1, which makes that a 7. So this cannot be 1. This has to be a 1 here because there's no other place for it. Again, this could be 3, 4, 6, and 8. But the problem is... we have actually many problems here. One of these has to be a 3. Did I mess up again? Maybe. Can't be. Oh, it could be 3, 5, 7 this way. And I think that's what it has to be. Yeah, I think it has to be 3, 5, and 7 this way. I forgot about this part, too. Yeah, it's a little tricky, actually. Making too many assumptions here. But this does, I think it does have to be 3, 5, 7 this way, because there's no other combination that works, right? 1, 5, 9 is not possible here. 1, 6, 8 eliminates 6 and 8 here. If we tried 1, 5, 9 this way, well, we can't because there's no 9 here. 1, 6, 8 doesn't work here because then we eliminate all possibilities here. So it has to be 3, 4, 8 or 3, 4, 7 or 4, 5, 6. But 4, 5, 6 doesn't work because one of these two has to be a 3. And to get out, you can't get, you either access the 9, which is not possible anymore, or you have to go this way, which requires a 3, which means the remaining two digits must add up to 12. So it's either 4 and 8, which is not possible because of the remaining digits. If it's 4 and 8, this becomes 5 and 6. And this can't, that would eliminate all possibilities for that cell. Or it's 3, 5, 7, which makes this 3, 5, and 7. And the rest we can figure out from Sudoku. This can't be 3 because of this 3, so this is a 6, which makes that a 3. This can't be 5, so this must be 6. That makes that a 5, which makes that a 6, which makes that an 8, which makes that a 6. This can't be 9 because of this 9, so this is 7, 9. This can't be 5 because of that 5, so this is 4 and 5. This can't be 6 because of that 6. So this is 4, this is 6, this is 4, and this must be an 8. Yeah, I mean, this one would just needed to be careful about um, making too many assumptions. I guess the cage was a good assumption here to make, but I think it was this one that was a bad. I made a bad assumption there, and I did make a bad assumption here, but this was very limited anyways, so that was okay. Yeah, I guess just be a little careful about how you're proceeding with these types of puzzles with limited information, I guess. Other than that, it's not that difficult as long as you just are very careful about how you how you go through, right? Anyways, this is the last part of the orange again. Um, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.